All right, I want to go over the greenhouse effect, kind of explain what it is and why we have it. So, the greenhouse effect is a very natural process that happens because certain gases in Earth's atmosphere are able to trap heat. So, not all of the gases in Earth's atmosphere are able to do this. So, the two major components of Earth's atmosphere are nitrogen and oxygen. So, they don't contribute to the greenhouse effect. Greenhouse gases are those that are able to trap heat. And the three major ones are carbon dioxide, methane, and water vapor. So, the greenhouse effect is important because it's one of the things that allows Earth to be able to sustain life. So, the fact that we have oxygen in our atmosphere is one of the big reasons why we have life on Earth. And the fact that we have water on Earth is another reason. But the greenhouse effect is just as important as having water and having oxygen to breathe. So, this is a very important process in terms of global climate change and global warming. So, what we see now is that activities that we are doing, like burning fossil fuels via transportation or energy production and deforestation, they're changing the amount of greenhouse gases that are in the atmosphere, which is leading to kind of this runaway greenhouse effect, which is going to be a problem in the future. And it already is a problem. So, I drew a little diagram. Normally, I would draw this on the board and walk you guys through it, so I'm going to try to do that with this video. So obviously this is not drawn to scale, but what I have tried to show here is that we have Earth. Above Earth, we have a very thin blanket of air called our atmosphere. I tried to draw more of these little dots towards the surface. These dots represent gases in the atmosphere, particularly greenhouse gases. So I know it's not perfect, but just bear with me here. So is a greater concentration of gases towards the surface because the closer you are to the surface, the greater the air pressure is. There's more air pressure because gravity is always bringing things in. So gravity is a center-seeking force, pulling things towards Earth's center. So there is a greater concentration of gases towards the surface. It gets thinner and thinner as you move out towards outer space. So that's what I attempted to draw there. So from the sun comes very short-wave, high-energy radiation, mostly in the form of ultraviolet invisible light. So remember, the electromagnetic spectrum is arranged by wavelength or frequency. So your shorter wavelengths are associated with a higher frequency, higher energy radiation. So from the sun, that radiation heats Earth's surface. Things that are heated naturally re-radiate some of that heat. So, after the sun's energy heats Earth's surface, some of that energy is re-radiated outward from Earth back to space. We call that energy coming from Earth, we call it terrestrial. Terrestrial is relating to Earth. So, we have very high energy, short wave radiation from the sun coming in, heating Earth's surface. Earth's surface is now warm and re-radiates some of that energy back. What's important is that it is not re-radiating in the same form of radiation. It's re-radiating more of a longer wave, lower energy radiation that's mostly in the infrared portion. Infrared light is associated with heat. So, this long wave radiation is absorbed by particular gases in the atmosphere called greenhouse gases. So, carbon dioxide, CH4, methane, um, water vapor, and some other ones as well. But CO2, carbon dioxide, and CH4, methane are the two big ones that we are concerned about. Water vapor produces most of Earth's natural greenhouse effect. But because the amounts of CH4 and CO2 are increasing so rapidly, it's causing kind of an increased greenhouse effect. So, after greenhouse gases absorb some of that energy, they re-radiate it back to Earth, or they re-radiate it to another greenhouse gas molecule, or some of it gets re-radiated out to space. What's important here is that that re-radiated energy can go back to Earth or to another greenhouse gas molecule, and that increases the warming. So this is what produces the greenhouse effect, is the absorption and re-radiation of this long wave terrestrial radiation. So that is one of the misconceptions about the greenhouse effect, is that it's really related to solar energy. It is, but solar energy, this shorter wave, higher energy radiation, is not absorbed by greenhouse gases. What is absorbed by greenhouse gases is this longer infrared radiation. That is what is producing the greenhouse effect, not shortwave radiation, but it's this longer wave terrestrial radiation that produces the greenhouse effect. So, to summarize, solar energy reaches Earth in the form of shortwave, high energy radiation. That energy heats the Earth's surface, and Earth re radiates some of that heat. Think about getting a sunburn at the beach. Later on at night, your skin is very hot because it's re radiating some of that energy it has absorbed throughout the day. So, similar kind of thing with Earth. At night, when Earth is cooling off, it's re radiating some of that heat it absorbed during the daytime. So that heat from Earth we call terrestrial radiation is re-radiated more in the long wave infrared portion of the electromagnetic spectrum. That long wave radiation is absorbed by particular greenhouse gases in the atmosphere, mainly these three: carbon dioxide, methane, and water vapor. Those greenhouse gases radiate some of it back to Earth, to space, or they radiate it to another greenhouse gas molecule. So, our next big topic will be about global climate change. So, understanding how the greenhouse effect works is very important in understanding how global climate change works, because we are dumping a whole bunch of greenhouse gases into the atmosphere, leading to an increased greenhouse effect. Because greenhouse gases are going to be able to absorb some of that re-radiated energy from their neighboring greenhouse gas molecules. The more we put in there, the greater the greenhouse effect is going to be, leading to global warming or a warmer Earth, and that is what is influencing global climate change. So I don't really like to use the term global warming, because that implies that everywhere on Earth is potentially going to get warmer. So while yes, Earth's temperature is increasing overall, that doesn't mean that everywhere on Earth is going to experience warmer climate. Instead, we'll see some changes in global climate as a result of this increased greenhouse effect. And we will get more into that after spring break when we start looking at global climate change. In this slide, oh, I forgot. Here is this picture of the whole thing. You can pause the video here and take a look at it. And I also put in this diagram as well. So same kind of thing. You can pause the video here and take a look at this.